So, good morning, everybody. So, in this lecture, we will discuss on the application of Bernoulli's equation, which is the Pitot tube. So, Pitot tube is used for measurement of velocity in the case of open channels like canals or in pipes. So, it is used mainly for measurement of velocity. Now, let us go into this topic and see how the Pitot tube is used to measure the velocity. And first, what is the Pitot tube? What is the principle of Pitot tube? How you derive the equation for velocity in the case of Pitot tube? One after the other, we will take it up and then pursue it. So, the in this lecture, we are discussing about Pitot tube. It's a device used for measurement of velocity in case of pipe flow in open channels. Open channels means you can take it as canals. Canals, basically. So, what is the principle actually on which this pitot tube functions? For example, what is pitot tube first? It is a, a tube bent at right angles. It is a tube bent at right angles. This is just a tube bent at right angles. This is what we call it as a pitot tube, right? This end is just like this. There will be an opening like this. So this is kept actually in a canal. Now, wherever you want to measure the velocity, we will insert this right angled bent tube into the flow, and I want to measure what is the velocity of flow at this point, at this depth actually. So at that depth, if we keep it, what is the principle here? Suppose if the velocity of the fluid is somewhere here, it is V at section 1. What happens the moment the fluid comes to this nose of this pitot tube, which I call it as section 2? Here, when once it comes here, the velocity of flow becomes 0. When the velocity of flow becomes 0, the velocity head will be converted into pressure head, and here the water level rises above the free surface. Above the free surface. And by measuring this pressure head, we can find out what is the velocity. So the principle it is based on, we slowly listen, it is based on the principle that if the velocity, what I have done is same, if the velocity of flow at a point, velocity of flow at a point becomes 0. That's what exactly we have made by inserting the pitot tube. Is 0. The pressure there is increased due to conversion of the kinetic energy into pressure energy. Now you see what I have done. It is based on the principle that if the velocity of flow at a point becomes zero, here the velocity of flow becomes zero, the pressure there is increased. Pressure is increased, which I have shown. Why pressure is increased? Due to conversion of kinetic energy into pressure energy. So just now I told it's a tube, actually a right angle bent tube, basically, which is having a opening at the end at section 2, that means at the nose. So now what happens, the lower end which we are keeping it in the water, actually in the fluid, which is now what will happen when the flow is coming into it, nearer to it, the flow with a velocity v, when it comes to the pitot tube, the flow velocity becomes zero, and when the velocity becomes zero, the pressure there is increased, the kinetic energy is converted into pressure energy. That is the principle. Now let us take it. Consider 2 points. Consider 2 points, 1 and 2, at the same level, in such a way that point 2 is just at the inlet of Pitot tube, and point 1 is far away from Pitot tube. Point 1 is exactly any location in the stream, you can locate it and then keep it. It need not be nearer to the Pitot tube, far away from the Pitot tube. Only the condition is both the points away from the Pitot tube. Only condition is both the points should be at the same level. 1 and 2 should be at the same level. Now let us take it. What is P1 and P2? P1 and P2 are the pressures at section 1 and section 2. At point 1 and point 2 are section 1 and section 2, whatever it is. V1 and V2 be the velocities at point 1 and point 2. That H is equal to depth of, basically, tube in the liquid. What is the depth of tube in the liquid? Small h is a rise of liquid in the tube above free surface. So that is next. So if that is the case, now if you apply Bernoulli's equation, so applying Bernoulli's equation between point 1 and point 2, between point 1 and point 2. At point 1, what is the, basically the pressure head is how much? It is capital H. What is the velocity head? It is v squared by 2g, v1 squared by 2g, plus basically the datum, because both are at the same level, the datum will not come into picture actually. Even if I write z1 is equal to, what is pressure head here? Where pressure head is increased, h plus h, velocity head becomes 0, z2. So these two will not be there because z1 is equal to z2, because both points are at same level, both points at same level. So therefore, h plus v1 squared by 2g is equal to h plus h, or v1 squared by 2g is equal to h plus h minus h, it is equal to h, or v1 is equal to root 2gh. So this is what we call it as theoretical velocity. Please remember the velocity to pressure conversion. How to do it is velocity is equal to root 2 gh. So now this is what we call it as theoretical velocity, but actual velocity is equal to some c into root 2 gh, where c is the coefficient of basically the velocity of the coefficient of velocity or coefficient of Pitot tube, where c is called as coefficient of Pitot tube. Generally, it will be around 0.98. So this is how the equation is used for measurement of velocity. So the velocity of flow by in a pipe, how to measure, because now I have shown you in a canals how to measure the velocity of flow in a pipe using pitot tube. Right now, for example, you take there are three cases. One case is pitot tube along with a vertical piezometer. The second case is pitot tube connected to a piezometric tube. Third one connected to it is pitot tube connected to a vertical piezometer. Connected by differential manometer. Connected by a U tube differential manometer. Fourth one pitot static tube. So what each one after the other I will show you with sketches and explain to you. For example, you take this is a pipeline. Imagine that this is a pipeline. Right, this is the center line of the pipe. Now what I will do is the first case is you insert a vertical piezometer here, right? Then now insert the pitot tube here, right? Now because of the static pressure here it will be up to here, and because of here the pressure is being reduced to the velocity being reduced to zero, the pressure is increased. So measure these two levels. So this is what we call it as H. So this is pitot tube, this is piezometer. So now measure the difference between these two things. So now find out what is V is equal to C root 2 GH. This is first principle. This is how the flow is. The first one actually. The same second one, a little bit modification is suppose the same pipeline. If that is the case, now actually here it is a center line of the pipe. So how it is now? First thing is if I take first. So this is the piezometer. Sorry, pitot tube. So pitot tube is arranged here like this. Now what we will do? This pitot tube is and piezometer is connected like this. Now these two are connected by a tube, right? If you connected, but so because of the pressure here it will be more, pressure here it will be less. So this is how it is going to be a tube. So measure the difference h and then do it. This is second one. So second here also v is equal to c root 2g h. This is h. Third one is again you take a pipe. So this is how the flow is taking place. So in the third again what we are doing now you take the piezometer or the pitot tube. So this is how the pitot tube will be. Right? After the pitot tube what I will do here we have a differential manometer. So this is a differential manometer. Right? What we are doing it one piezometer we are keeping it here. Right? Now what I am doing I am joining actually. So pitot tube I join to YouTube differential manometer. Even the pitot tube also I joined. So what is the difference here? I have measured the if it is a YouTube differential manometer, right? So I measure what is this x. So even once x is measured, h is equal to x into sm by s minus 1. Calculate h and v is equal to c root 2gh. This is third one. So that means using a differential manometer that which we are doing it. Now but the most popular thing is final thing is which we are going for a pitot static tube. Pitot static tube consists of pitot static tube. It consists of two concentric tubes. Please remember it consists of two concentric tubes. One inside the other with same annular space between them. Next, the outlet of the outlet of these two tubes is connected to a differential manometer. Right? And and by measuring the deflection, we can find out velocity. So instead of having actually one pitot tube and one piezometer connecting it to them, all of that we will be having only one tube. So it also appears as if it is a pitot tube. There's nothing else. But only thing is in this, there are two concentric tubes. It's not one tube. In the pitot static tube, there will be an outer tube, there will be an inner tube. These two are actually one inside the other, and there will be an annular space between the two tubes. And now these two, when once the outlet of them, both of them are connected, both these tubes at the outlet are connected to a differential manometer. So now I will show you how they are also. Just coolly observe it. For example, now only I am showing the static tube. So this is the inner one actually, right? The outer one will be like this. So there are two tubes, outer tube, inner tube. Inner tube is a straight tube, outer tube is having holes on it. The outer tube is having holes on it. For the inner tube, there is only one hole at the beginning actually here. Whereas for the outer holes on the periphery, there are holes actually. Now if I see it, the inner tube straight away you take it outside. It goes outside like this. The outer tube actually it goes like this, right? So this is the outer tube and this is the inner tube. These are the two tubes actually. So this is outer, this is inner, both. So now what we are going to do, suppose now I kept it in the water. So this is the pipeline. Now what I will do actually, both of them if I take it here, these two ends are connected to, this is for example, if you take this I will show you here figure basically, because here it is very difficult to show, or otherwise I will show you. Okay. So now I will connect it actually. So how it is, if I say it, this is one, two. So this is YouTube animate. So now these are also connected. Right now we have connected. So depending on the pressure, because the inner tube is the pitot tube, where naturally if I take it, the inner tube is only the pitot tube actually. Whereas the outer tube, if you take it, there actually it will be. So here because of the total pressure, it will be pushed down. Whereas here it is pressure is less, naturally it pushes up. So the outer tube, if you take it, is measuring only the hydrostatic pressure actually, whereas the inner tube is measuring both the the hydrostatic pressure plus the dynamic pressure, which is being converted into pressure head. So now measure the this difference. This difference, if you take it, h is equal to x into sm by s minus 1. The advantage of pitot static tube is only it is just like appears as a pitot tube, but there will be two concentric tubes, one's inside the other. The outer tube, this outer tube measures actually, we call it as stagnation pressure. It measures the stagnation pressure. Inner tube measures the static pressure. What is stagnation pressure? It consists of both static pressure plus the dynamic pressure. What is this dynamic pressure? Dynamic pressure means the velocity of flow becomes zero. When once the fluid touches here, it becomes zero. There, the velocity head is being converted into pressure head. That is what we are talking about. So, using this, now finally concluding the again, you can find out V is equal to C root 2 GH. So, finally, I wish to conclude this chapter actually. Conclude conclude with this topic with some of the points. This pitot tube in the Pitot tube always measures actually, it measures the stagnation pressure. Remember it. The static pressure has to be measured by a piezometer, right? Then naturally stagnation pressure is equal to static pressure plus dynamic pressure. Now from where dynamic pressure comes is when velocity becomes zero, velocity head is converted into pressure head, right? So therefore remember stagnation pressure head is equal to static pressure head plus V squared by 2G. So this point we should remember, and that's what exactly we have used in this principle. So here I will stop this thing, and the problems on this the Pitot static tube are very simple actually. Straight away using it and then finding it out, you try it out actually. With this, I will stop this topic also here, and then we will go into the next topic in the next class.
Like, share, and subscribe. Hit the bell icon for more updates.